Welcome to SureSolve. This is Atanu Chaudhary. In this fourth video on how to solve SSC CGL third algebra problems quickly, we'll solve three difficult third algebra problems. We'll solve the problems using most of the important third algebra techniques along with two very useful algebraic expression simplification techniques. Let's see the first problem. The first problem is, if x equal to root 3 by 2, then the value of root over 1 plus x divided by 1 plus root over 1 plus x plus root over 1 minus x divided by 1 minus root over 1 minus x is option A 2, option B 2 minus root 3, option C 2 by root 3 and option D 1. With x as surd, root over 1 plus x and root over 1 minus x are both double square root surds. By this we mean the root 3 of x will be under another square root. So we must express both 1 plus x and 1 minus x as square of surd terms. That is a must. This is the main difficulty of this problem. How to convert 1 plus x or 1 minus x as square of surd terms. Taking 1 plus x first, root over 1 plus x is equal to root over 1 plus root 3 by 2. In the square of sum of surd expression, the surd term will always be the middle term and we'll have the coefficient of 2. But here we don't have the coefficient of 2 with the surd term of root 3 by 2. So we'll forcibly introduce coefficient of 2 with the surd term by multiplying and dividing 1 plus root 3 by 2 by 4. This becomes half root over 4 plus 2 root 3. Root 3 whole square plus 1 square is 4. So 4 plus 2 root 3 you can easily see to be equal to root 3 plus 1 whole square. Taking it outside the square root, we have half root 3 plus 1. This is the breakthrough. For your information, there are two types of double square root surds. This is a more difficult type of double square root surd where coefficient of 2 was not there with the surd term. An example of an easier double square root surd is 7 plus 4 root 3. You can see one term is 2 and another term is root 3. 2 square plus root 3 whole square is 7. So this is root 3 plus 2 whole square. This is easy to convert. Okay. Coming back to our problem, in the same way, we'll get root over 1 minus x equal to half, this time root 3 minus 1. By analyzing the direct expression, we decide to substitute the values of root over 1 plus x and root over 1 minus x directly, getting root 3 plus 1, taking the 2 to the denominator, divided by 2 plus root 3 plus 1 plus root 3 minus 1 divided by 2 minus root 3 minus 1. That's simple. Equal to root 3 plus 1 divided by 3 plus root 3 plus root 3 minus 1 divided by 3 minus root 3. Now we'll apply the surd factoring technique by taking out root 3 out of 3. This becomes root 3 plus 1 divided by root 3 into root 3 plus 1. This is a special technique, small technique but very useful. Plus root 3 minus 1 divided by root 3 minus 1 equal to 2 by root 3. Straightforward. Answer option C, 2 by root 3. This is easy to do in mind if you know how to do it. Let's solve the next problem. The second problem is, If a equal to root 6 minus root 5, b equal to root 5 minus 2, and c equal to 2 minus root 3, then the correct comparative relationship between a, b and c is option A, b less than a less than c, option B, a less than b less than c, option C, b less than c less than a, and option D, a less than c less than b. This is a third comparison problem. But we cannot compare the variables because we cannot estimate the values of the variables in this subtractive form. But we discover a special pattern in the terms. Just notice, between a and b, root 5 is common, and between b and c, 2 is common. This shows us a clear path to the solution. We'll convert root 6 minus root 5 to root 6 plus root 5. Similarly, root 5 minus 2 to root 5 plus 2. And 2 minus root 3 to 2 plus root 3. What we'll do, we'll rationalize the numerator this time, not the denominator. Getting a equal to 1 by root 6 plus root 5, b equal to 1 by root 5 plus 2, and c equal to 1 by 2 plus root 3. Notice that the difference of squares of two terms of each variable is 1. Now we can compare the first denominator with the second denominator. Root 6 plus root 5 with root 5 plus 2. Root 5 is common. Root 6 is greater than 2. So root 6 plus root 5 must be greater than root 5 plus 2. Denominator of a will then be larger than the denominator of b, which will mean that a will be less than b. The lesser greater relationship of the denominators will be the inverse of the relationship between the actual variables, because one will be divided by a larger number for a compared to b. Now we'll compare the denominators of b and c. Root 5 plus 2 with 2 plus root 3. 2 common and root 5 greater than root 3. So root 5 plus 2 will be greater than 2 plus root 3. Here root 5 is greater than root 3. In the same way then, b will be less than c. Combining these two, we get the answer as a less than b less than c. Option B is the answer. Let's solve the next problem. This is a large problem of third simplification. But good sign is the balanced pattern of the target expression terms. Because of this pattern, we should be able to solve the problem easily and quickly. First, we rationalize and simplify the value of x. X equal to 2 root 15 multiplied by root 5 minus root 3. We have multiplied the numerator and denominator by root 5 minus root 3. The resulting 2 in the denominator reduces the 4 in the numerator to 2. So this is the value of x. We want to substitute the value of x directly in the target expression, as that will make the expression too complex to handle. Now we'll apply the first algebraic simplification technique of numerator simplification. By adding or subtracting 1 from a term, we'll eliminate one of the terms of the numerator. This is possible because of the special pattern of the numerator and denominator. All 4 terms are same in value, but 2 terms are opposite in sign. With this special pattern, you can always apply this technique. Question is, which of the 2 terms, x or root over 20, will eliminate? This time we'll apply a second more general principle of selecting the more complex term to eliminate. That follows common sense. The value of x is much more complex than root over 20, so we decide to eliminate x from the numerator by subtracting 1 from each of the terms and compensating by plus 2, getting 2 into 2 root 5 divided by x minus 2 root 5 plus 2 into 2 root 3 divided by x minus 2 root 3. We have converted root 20 to 2 root 5 and root over 12 to 2 root 3 plus 2. We have subtracted 1 from the first term so that x is eliminated, leaving 2 times 2 root 5. Same with the second term. In selecting the term to eliminate from the numerator, we have applied a general principle. That is not a technique, that's a principle. Now we'll apply the second technique of simplifying the numerator by dividing the denominator with the numerator. We use this technique to frequently simplify the fraction terms. Dividing the first denominator by 2 root 5 and the second by 2 root 3, we get this is equal to just 2 by, in x only root 3 remains, into root 5 minus root 3 minus 1, and in the second term 2 by, this time root 5 remains, root 5 minus root 3 minus 1, much simplified form, plus 2. Root 3 multiplied by root 5 is root 15 and second term is minus 3. So the first denominator is root 15 minus 4 equal to, the first term is 2 by root 15 minus 4 and the second term is 2 by, this is 5, 5 minus 1 is 4 and the second term is root 15. Just the opposite sign, 4 minus root 15. How convenient, plus 2. The first two terms are equal and of opposite sign, so they cancel out, leaving just 2. Answer, option B, 2. Not so difficult as it seemed in the beginning. This problem also could be solved easily in mind. To sum up, we have learned how to deal with double square root surds in solving the first problem. In the second problem, we have learned surd composition technique. And in the third problem, complex surd simplification techniques. Okay, that's it. If you have liked this video, subscribe to our channel. Thanks for watching.